Just a heads up, I do have a warm-up problem for you guys to do. So make sure to take a look at this when you get the chance. Morning. Morning. For those of you that just came in, I have a warm-up problem for you guys to do. There we are. Okay, so I guess technically it's now 8:30, so we'll go ahead and start. So, but like I said, I'll just give you guys an extra minute to do the warm-up problem. So, another way you can think of this is just saying, if you want an extra hint, evaluate the integral of 7 times sine of x plus 6 over pi squared x and then dx. If you want one way to think of it. So, for those that did the warm-up, what did you guys get for your answer? Go ahead.
Negative 7 cosine x plus 3 over pi squared times x squared plus c.
Good. Yep. So let's go ahead and go over that. So in this case, what we can do is, because we have an integral, we can focus on term-by-term differentiation. And then if there's a constant hanging out, we can take outside the integral as necessary. So what that means is we have the integral of 7 times sine of x dx plus integral of 6 over pi squared times x dx. And then we take the constants outside. We have 7 times integral of sine of x dx plus 6 over pi squared times integral of x dx. So since we know the antiderivatives of sine and x, that means we get negative 7 times cosine of x plus 3 over pi squared times x squared. And then because we have indefinite integration, we have to incorporate plus c. Okay? Okay, so any questions on that part? All right. So the warm-up was basically just stuff we did already in the last lesson, but now we did it here just because we're going to need this for the next example, which says, given the initial value problem, which is abbreviated IVP, we need to find y of 2 pi. So basically, we have to figure out what's going on with this function y, such that its derivative is 7 times sine of x plus 6 over pi squared times x. But the thing is that we're also given this additional data point, y of pi equals 7. So if we just had the derivative, the only thing we could do is just the warm-up. But now, we have this additional data point, so now we can use this to actually figure out what c is. So, how to solve IVPs? So let's just do a quick recollection of last time. So integrating a function. So integrating a function gives the general solution. So I'll just say aka general antiderivative. In adding plus c. Okay. So basically, as an example, we have the general solution of this IVP right here. So if we just integrate this function right here, we just get the general solution, which ends up corresponding directly to the answer in our warm-up problem. But now we have an additional data point. So if given an additional data point, use this to solve for c to get the what's known as the particular solution. Okay? Alright. So if we use this reasoning, that means we end up with the following. So here's what we have. So we have y prime equals 7 times sine of x plus 6 over pi squared times x. So the thing is that as per the warm-up, we should already have that y of x equals negative 7 times cosine of x plus 3 over pi squared times x squared plus c. So we say, all right, well, that gives us our antiderivative slash general solution slash general antiderivative. So, like I said, if we did not have this data point, this is the farthest we could go. But now we do have this data point, so now let's figure out what c is. So now we say, all right, let's go ahead and let x equal, in this case, pi. So we have y of pi. So if we let x equal pi in this, well, what happens? So we have equals negative 7 times cosine of pi plus 3 over pi squared times pi squared plus c. So before we set this equal to 7 as per the assumption in our problem, let's go ahead and clean this up a bit. So we have negative 7 times cosine of pi. Well, what does that simplify to? So what's cosine of pi, first off? Negative 1, right? So that becomes negative 7 times negative 1, so just 7. And then plus 3 over pi squared times pi squared, so those cancel. So ultimately we're just left with 7 plus 3 plus c, and then because of our assumption in the problem, this has to equal 7. So then a quick bit of algebra later should then tell you that c is then equal to negative 3. Right? So as a result of this, that tells you that the particular solution is then y of x equals negative 7 times cosine of x plus 3 over pi squared times x squared minus 3. Okay? So this right here is the particular solution. So particular or solution. Okay? So now we say, all right, well, it's good now we have this function, but remember, the problem states that we got to figure out what y of 2 pi is. So now we have to figure out, well, what is y of 2 pi? So if we just let x equal 2 pi in our particular solution, well, what happens? Well, we get negative 7 times cosine of 2 pi plus 3 over pi squared times 2 pi quantity squared minus 3. So how does this simplify? Well, let's go term by term here. So we have negative 7 times cosine of 2 pi. So what would that simplify to?
Negative 7.
Yeah, negative 7, because cosine of 2 pi is still 1, so we just have negative 7. Okay? But what about the second term? So we have 3 over pi squared times 2 pi quantity squared. So what would that become?
Well,
Yeah, just 12, right? Because we have 3 over pi squared. And in this case, 2 pi squared, you have to distribute the square into both factors. So we have essentially 4 pi squared now. Okay? So then at this point, we can cancel out the pi squareds. And then we're essentially just left with 12 as you said. And then minus 3 because that's the last term. So essentially, we're just left with negative 7 as the first term plus 3 times 4 is 12 minus 3. And that should pretty quickly simplify to just 2. So then as a result, well, y of 2 pi is then just 2, which is the desired answer that we were looking for. Okay. So that's example 1. So any questions on that? Okay. All right, so now let's move on to, does anyone still need this? Okay. So moving on to the next example. So now we're going to move on to some more wordy problems. So we have the rate of growth, dp/dt, of a population of zebras is proportional to the cube root of t with constant coefficient of 8. So let's take a look at what this means first because, well, there's a lot going on. So p is a population size and t is time in months. Okay? So let's take a look at what this means. So we have that we have dp/dt is proportional to the cube root of t. So let's take a look at what this means first. So we have dp/dt is proportional to the cube root of t. So if you recall, what that means is that we have dp over dt. If we say it's proportional to the cube root of t, that must mean it's equal to some constant k times the cube root of t. So just k times the cube root of t. So that's what this part gives you. So the constant coefficient of 8 part, constant coefficient of 8, what that tells us is that, all right, that must mean that this constant k has to equal 8, is that what that tells us. So we have 8 times the cube root of t, or if you prefer, 8 times t to the 1/3. Okay? So that's what that tells us. So as a result of this, that says, all right, well, if you recall, notation-wise, dp/dt is the same thing as p prime of t, right? So that's what, so basically now we have a antiderivative problem to figure out. But as you might have guessed, well, with this context of the lesson, what we have to do is we have to be able to figure this out as an initial value problem. So let's take a look at the next sentence in response to that. So if the initial size of the population is 800, we need to find the population after 10 months rounded to the nearest integer. So what that says is, all right, so if P is population size at time t in months, what that says is, all right, well, we got to solve P prime of t equals 8 times t to the 1/3. And then we're also given the initial condition as what? Not quite. So remember, so P of something equals 800. I agree with that. But remember, the initial size is 800. So in this case, if you recall, initial directly corresponds to t equals 0. So P of 0 is equal to 800. So I'll just say initial. If you see the words initial, treat that to mean that same thing as t equals 0. Okay? Okay, so we have to solve this IVP, and then it says find the population after 10 months. So that means we have to say, all right, once we solve this IVP, we solve this, and then we have to find what? We have to find what quantity?
P of 10.
P of 10. Good. Okay. Okay, so now we have that. So let's go ahead and solve this IVP then. So we have, let's see. So if we want to figure out P of t, well, let's first take the antiderivative of P prime and see what we get. So we have 8 times t to the 1/3. But now in this case, because our input variable is t, we now have to integrate with respect to t here. So using this reasoning gives us that the general antiderivative is then what? If you apply the antiderivative power rule from Monday. Go ahead.
Is it 6t to the 4/3 plus c?
Right. Because in this case we have 8 times, well, if you apply the antiderivative power rule, we have t to the 4/3 over 4/3 and plus c. And then so if we simplify this a bit, we should end up with equals 8 times, well, 3/4. If we multiply by the reciprocal of 4/3 times t to the 4/3 plus c. So 8 divided by 4, that's 2, so we should end up with 6 times t to the 4/3 plus c as our general antiderivative here. So in this case, that gives us, all right, this is just P of t as the general antiderivative. So as per the last problem, let's go ahead and plug in our initial data point to figure out what's c equal to here. Okay? So in this case, if we let t equals 0 in here, well, in this case, we should just end up with a big fat, just c, because this first term goes away. But in response to that, well, we also have that P of 0 is also equal to 800. So that should pretty quickly give you c here. So we have P of t, the particular solution is then 6 times t to the 4/3 plus 800. So now all we got to do here is just let t equal 10 to get our answer here. So if we do that, and keep in mind we're rounding to the nearest integer, then what's our answer going to be here? In this case, you will need a calculator here. you guys a second to look at that. So what would you guys get as your answer here?
929.
Good. So we have 6 times, well, 10 to the 4 thirds plus 800. So putting that into a calculator and rounding to the nearest integer should give you 929 as your population of zebras at 10 months. Okay, so that's example 2. So any questions on that one? Okay. So I'll give you guys a second to write that down. Okay. So moving on to our next example. So we have a starship balloon rises vertically with a velocity of 6 feet per second. A small ball is released from the balloon when it's 1,440 feet above the ground. Now if A of t equals negative 32 feet per second squared, denotes the acceleration due to gravity, we have to say, all right, how many seconds after its release will the ball hit the ground? Round your answer to 2 decimal places, and we have to figure out at what velocity will it hit the ground. All right, so let's do a bit of setup here. So I'll just call this part A for now. So let's do a bit of setup. So here's a picture of what's going on. So here's the ground. And we have this balloon that's rising vertically. So here's our balloon. I'm just going to denote this as SS for balloon, or starship. And what we're going to do is we're going to have a little small ball, this guy right here. So what's happening is that the balloon is rising vertically with a velocity of 6 feet per second. Okay? And the ball is released from the balloon when it's 1,440 feet above the ground. So the ball gets cut from the balloon at this height. Okay? So here's what happens. So here's our picture of what's happening. So basically, what happens is that in this problem, you can assume that at t equals 0, that directly corresponds to the moment the ball is cut from balloon. Cut from balloon. Okay? So just to recall a few things. So in this case, we're given the acceleration due to gravity here. So in this case, if we want to figure out after how many seconds will the ball hit the ground, or when the height is equal to 0, well, that should probably be a good enough indication that we got to figure out the height function somehow. So let's do a quick recollection of some things. So recall. So if you recall A of t, so we say, all right, so we say the acceleration of t, so how is that related to the velocity of the function, or the velocity of the ball? So how do we, let's say we have the velocity, how do we get the acceleration from that? Take the derivative, right? Okay. And then because the velocity of the ball can be obtained from the position by differentiating in similar fashion, that means that we have that the second derivative of position slash height is equal to our acceleration. Okay? So like I said, we need to figure out when the ball hits the ground. So we have ball hits ground, ball hits ground when S of t equals 0. So first solve, or say first need to solve. Okay, so first need to solve the following. So we have, in this case, we're going to be dealing with an initial value problem again, but in this case, now we have to deal with the second derivative with two data points. So we have s double prime of t equals negative 32, as per what we have per our assumption here. And we'll also need two additional data points as well. So in this case, we have, all right, we're given that the height when the ball is cut from the balloon is 1440. So since that directly corresponds to t equals 0, that should tell you what? So s of 0 should then equal 1440. Okay? And then in a similar fashion, because the balloon and therefore the ball have velocity 6 feet per second when the ball is cut from the balloon, what should that tell you about the extra data point that we need here? So if the, yeah?
Is it s prime of t equals 6?
So close. S prime of something equals 6. So remember, so when the moment the ball is cut from the balloon, it'll still have 6 feet per second, right? As its velocity. So in this case, we say the moment the ball is cut from the balloon, it'll still have velocity 6. So instead of s of t, it should be s of 0. Okay, so now that we have this IVP, let's go ahead and use this to figure out s of t from this. Okay? So first, in this case, we sort of have to work our way backwards from this. So in this case, if we want to get to s of t from the second derivative, well, we probably need to figure out the first derivative, first. So first find s prime of t. So that's going to be equal to the integral of s double prime of t dt. So if we do that, we say, all right, well, we've got to figure out the integral of negative 32 with respect to t. So if we do that, then a pretty quick application of power rule should then tell you that this is equal to what? Or antiderivative power rule, I should say. But go ahead.
Negative 32s.
Well, in this case, negative 32t, but yeah. And then plus c. Okay. Okay. So then from our initial data point, you should be able to pretty quickly figure out what c is. So what would that equal here?
6.
Yeah, 6, right? Because s prime of 0. In this case, if you let t equal 0 here, you just get c. But by our assumptions, this is also equal to 6. So that gives you that s prime of t is then equal to negative 32t plus 6. Okay. So that's the velocity at time t. So now let's use this to figure out the position at time t. Or height, or whatever. So next, find s of t, which equals the integral of s prime of t with respect to t. So we integrate negative 32t plus 6 with respect to t. What should our antiderivative of that be?
Negative 16t squared plus 6t plus 1440.
Yeah, so negative 16t squared plus 6t. And then to start off, let's do the general antiderivative of s of t first. So what I'm going to do is, so as to not confuse this with the c we have up here, I'm going to use a different letter, d. So I'm using d to distinguish from the c we already have here. So using different letter to distinguish from C. Okay? But essentially it's the same idea. So as you said, the constant d should be 1440 if you let t equal 0 here. So we have s of 0 equals d, just letting t equals 0 from this. So by our assumptions, that's equal to 1440. So that should give you the final, well, not really the final answer, but the position function, rather. The particular position function is equal to negative 16t squared plus 6t plus 1440. Okay. So now let's go ahead and say, all right, now we got our position slash height function. Now let's go ahead and actually figure out what we're supposed to figure out here. Okay, so now we say, all right, so to get A, we got to solve s of t equals 0 based off of what we established here. So we do that. We have negative 16t squared plus 6t plus 1440 equals 0. So if we do that, we say, all right, well, just by taking a look at this, it doesn't really seem like there's a nice way to factor this, at least not immediately. So what would your next thing you'd want to try and do?
Quadratic formula.
Quadratic formula, good. So, somebody else, can you remind me what the quadratic formula would give you in this context?
Negative 6 plus or minus the square root of 6 squared minus 4 times negative 16 times 1440 over 2 times negative 16.
Yep, good. So 2 times negative 16, good. Okay. So let's do a quick recap. So remember, the quadratic formula states that, we have t equals negative b plus or minus the square root of b squared minus 4ac, and all divided by 2 times a. So you recall that's what the quadratic formula states. So if we do that, we say, all right, well, negative b plus or minus, so we have negative b, so since b is 6, we have negative 6 plus or minus square root of 6 squared, then a is negative 16, c is 1440, so you just plug those in to get this part, and then 2 times negative 16 will be your denominator. Okay. So if that's the case, we say, all right, well, so we have that. So we have negative 6 plus or minus the square roots of, well, noting that we have a negative and a negative here, that means those two negatives should cancel each other out. So we have negative 6 plus or minus the square root of, so if you plug this part into a calculator here, then you should be getting 92,196 as your square root, and then all over negative 32. Okay? So in this case, that should give you 2 values of t that would satisfy the inequality, or satisfy the, not the inequality, the equation. So what 2 values of t would those be here, if you plug those into a calculator? So what's one such value of t that gives you the equation here is true for rounded to 2 decimal places? You might need a calculator for this, by the way. So here we have negative 6 minus the square root of 92196 over negative 32. And then the other one is going to end up being negative 6 plus square root of 92196 over negative 32. Okay. So plugging those both into a calculator will yield what? So if we start with this, so we should have, this is approximately equal to what?
So 9.68.
Yep, 9.68. Good. So that's one of them. But what about the other one?
Negative 9.30.
Yep, negative 9.30. Good. So that means, oh, well, wait a minute. We have two values of t that give us our inequality. So what do we need to do? But remember, our system here starts at t equals 0 here. So that means, all right, anytime past t equals 0 is okay, but remember, that means that anything less than 0 is out. So remember, our domain for these types of problems is t has to be greater than 0. So because of that, if you have any negative values of t for this inequality, for this equation here, that means that it's automatically out. So negative 9.30 is definitely out here. Okay? So that means your only option is positive 9.68. So that's going to be your answer for part A. Okay? So that tells you that the ball hits the ground at time 9.68. Okay? So that's part A. Now you might think, all right, well, not much room for part B, but you realize, well, wait a minute. I already have when the ball hits the ground, and part B just asks what velocity will the ball hit the ground. So all I need to do is just take the time I got from part A and then do what with it?
We're going to do velocity equation.
Exactly. So we have v of 9.68. So since v of t is equal to s prime of t, that's just s prime of 9.68. So just plug this into here, the s prime of t equation up here, and you should end up with approximately negative 303.64. And that should be your velocity when the ball hits the ground. Okay? Okay, and that's example 3. So, any questions on any of that? Okay. So, tell you what. Why don't I do this? So, does anyone still need this first off? Okay. So the next example I had planned was just another find the particular solution to the initial value problem, but we got quite a bit of time left, and if you guys were able to understand example 3 in terms of, finding the particular solution, then example 4 should not be too much trouble. So why don't you guys take a second to look at example 4, and we'll reconvene in about 9:15, which is in about 8 or so minutes. So if you want to look at this on your own, you can. If you want to pair up with someone, you can do that as well. So I'll give you guys some time to look at that. So how about it? You guys can about another minute or so. Alright, looks like we're all our pencils down, so let's go ahead and reconvene. So, we got to find the particular solution to this IVP. So basically we got to figure out what y of x is given all this data. So, as per example 3, we should probably start by figuring out the first derivative. So, first find y prime. So if we do that, we say, alright, well, what did you guys get for y prime of x?
X squared over 2 minus 2x plus c.
Yep. So in this case, what we have to do is say, all right, well, if we integrate y double prime with respect to x to get y prime of x, what we have to do is say, all right, well, y double prime is just x minus 2 dx. So then if we take the antiderivative of this, then we end up with x squared over 2 minus 2x plus c. So that's the general antiderivative. And then, so since this is y prime of x, how do we use this to get the particular solution given our data points? So if we plug in x equals 0 into our y prime function here, what should that quickly tell us about the value of c here?
Equals 3.
Yeah, just equals 3, right? Because y prime of 0, just like x equals 0 here, you get c, which is equal to 3. So then you should get y prime of x equals x squared over 2 minus 2x plus 3. Okay? Okay, so that's y prime of x. So now the last thing we got to figure out is, well, what's y of x? Well, so y of x equals, well, similar reasoning as in the last example should tell you you got to integrate y prime to get the general antiderivative of y prime. So if we integrate y prime with respect to x, we end up with, well, x squared over 2 minus 2x plus 3 dx. So then similar applications of power rule should tell you that y of x should equal what? Yeah?
I got 1 over 6 x to the third minus x squared plus 3x plus c.
Yep. Nice. So we have x cubed over 6 minus x squared plus 3x, and then plus, in this case I'm going to use d again so as to not confuse it with the value of c we have here. But you can still use c if you want, but I'm just using d to not confuse things too much. So now we have that, let's go ahead and say, alright, so this is y of x as the general solution. So if we let x equal 1 here, what happens? So we get y of 1 equals, let's see, 1 cubed over 6 minus 1 squared plus 3 plus d equals, in this case, set that all equal to 0. So if that's the case, what should you guys end up with as your value of d here? In this case, you should end up with a fraction.
I got negative 13 over 6.
Yep, I got me. Yeah, you should begin. Yep, that too. So we have, because we have 1/6 minus 1 plus 3 plus d equals 0. So if you simplify all this, this is just 13 over 6 plus d equals 0. So that should tell you that d is negative 13 over 6. D is negative 13 over 6. So, as a result, you should be getting that y of x is then equal to x cubed over 6 minus x squared plus 3x minus 13 over 6. And that's example 4. So, any questions on any of that? Okay, cool. Well, that's the lesson in a nutshell. So, with that taken care of, yeah. So because the exam on Tuesday through Friday, we're going to have our exam 3 review. So please come with questions if you have any, and make sure to do that extra credit review packet that I sent out on Monday if you guys want that extra credit. It's going to be very similar to the extra credit we did for exam 2. So just make sure to read the email from Monday about that so you guys have an idea of what's happening with the rules and regulations if you choose to take advantage of our final extra credit opportunity. But otherwise, I'll have extended office hours on Monday, and I'll see y'all then.
Have a good weekend.
Yep, you too.